All right, today we're talking about something huge, something that affects millions of students, the Great Math Wall. We're going to dive into why this one single subject so often becomes this massive barrier between people and their goals.
So let me ask you something. Have you ever been told, or maybe even told yourself, I'm just not a math person? You know that feeling? Like no matter what you do, math is just this obstacle you can't seem to clear. But here's a thought. What if the problem isn't actually you?
Well, according to some really important research by Dr. Ronnie A. Rodas, it turns out the problem might not be you at all. It might be the system itself. And that's what we're digging into in this explainer. We're going to break down his findings because his work on how math requirements really work in education, well, it's pretty eye-opening.
Dr. Rodas came up with this really powerful metaphor to describe what's happening. He calls it the Great Math Wall. And it's a perfect description, right? For so many students, math stops being just another class, and it becomes this giant, impassable barrier blocking their entire educational path. And listen, this isn't just some abstract idea. It's a very real problem. I mean, check out this quote from his research findings. It tells a story that is just tragically common. You have these capable students, right? They're acing all their other classes, but they can't graduate. Why? Because of one single mandatory math class they just can't get through.
Okay, and the data backs this up in a big way. Just look at this chart from the research. It is stark. There's this incredibly direct link. The more remedial or catch-up math classes a student has to take, the less likely they are to ever finish their degree. I mean, that completion rate just plummets with every single extra class. It's like the wall literally gets higher and higher.
So how does this happen? How exactly does one subject become this powerful gatekeeper? Well, Dr. Rodas' work actually pinpoints two key ways that this gate gets locked, shutting students out.
Okay, so there are two sides to this. On one hand, you've got what the research calls the structural wall. This is the literal physical requirement. You must pass this math class to continue, no exceptions. But then, on the other hand, there's this psychological driver. And this one is powerful. It's the anxiety, the fear of math, that's so strong it actually pushes students to pick different majors, even different careers, just so they don't have to deal with it.
You know, this all leads to a really critical question. Why? Why is this gatekeeper even there? Is it really about teaching us all a vital skill we need? Or is it actually doing something else entirely?
So the official justification, right, the reason we're all given, is that these high-level math classes build critical thinking and get us ready for a world full of data. Sounds good, but the research points out this massive disconnect with reality. Think about it. For so many careers, we're talking human services, the arts, social work, the day-to-day job almost never, ever requires you to use algebra 2 or trigonometry.
And this brings us to a key concept in the research called credentialism. Here's the basic idea. Maybe passing that tough algebra class isn't about proving you can do algebra. Maybe it's just a signal to employers that says, hey, this person has the persistence, the grit to get through a difficult challenge. So in that sense, math isn't really a skill, it's a filter. And here's where it gets really serious, because like any filter, this one is not fair. It doesn't affect everyone the same way. The research is crystal clear on this. The math wall is a huge issue of equity.
So who gets hit the hardest by this? Look at the breakdown here. Dr. Rodas' work shows a really consistent and troubling pattern. It's low-income students, first-generation college students, and minoritized students who are overwhelmingly, disproportionately placed into these long remedial math tracks.
And what's the result? It creates this vicious cycle. The very students who start with fewer resources are put on a path that is longer, more expensive, and way more difficult. They end up burning through their financial aid on courses that don't even count towards their degree. So the system, instead of helping, ends up making inequality even worse. Okay, but it's not all doom and gloom. The really great thing about this research is that it doesn't just point out the problem, it also shows us a way forward. So let's talk about some solutions, about how we can start to dismantle this wall.
The big idea here is getting rid of the one-size-fits-all approach. The traditional path, where every single student, no matter their major, gets forced down the exact same algebra to trigonometry pipeline. The alternative? Create different pathways that actually make sense for what a student is studying. Like, hey, maybe statistics makes more sense for a social science major, right? Or quantitative reasoning for someone in the humanities.
And does it work? Oh yeah, the data is incredibly compelling. Check this out. Students who take these alternative, more relevant math paths aren't just learning more useful stuff. They are way more likely to actually pass their math requirement and stay on track to graduate. I mean, the completion rate, as you can see, is just so much higher. This is a game changer. So, to wrap up the solutions, Dr. Rodis' study gives us some really clear, practical steps. First, make math pathways relevant to the major. Cut down on those long, draining remedial sequences. Give students support while they're in their credit-bearing classes. And, this is a big one, treat math anxiety like the serious policy issue it is. And finally, let's make sure the hoops we ask people to jump through actually line up with the skills they'll need for the job.
When you step back, all of this really boils down to one fundamental question. What is the goal of our education system? It forces us to redefine what it actually means to be ready for the world.
And the main takeaway from all this research is really clear. Let's be honest, nobody is saying math isn't important. Of course it is. Basic numeracy, being able to think with numbers, that's essential. But using advanced algebra as this rigid, universal filter for everyone, that's what's not working.
So I'll just leave you with this final question to think about. If the whole point of education is to prepare students for the real world, with all its different jobs and challenges, shouldn't our math requirements actually reflect that world?